Nobody told you the most important number in fat loss. Not your doctor, not your fitness app, not the treadmill display showing you calories burned. The number is not how many steps you take. It is not how long you walk. It is a specific percentage, a precise range of effort, below which your body burns stored fat as its primary fuel, and above which it switches to sugar and stops. Miss that number and you can walk for an hour every day for months and burn almost no meaningful fat. Hit it, and the same hour pulls directly from the visceral fat stores your body has been protecting for years. This video is about that number, the molecular biology behind it, the reason most people are walking at exactly the wrong intensity without knowing it, and the precise adjustment that changes everything. Stay with me, because once you understand why this works at the cellular level, you will never think about pace the same way again. Your body runs on two fuel sources simultaneously in constantly shifting ratios. The first is glucose, fast-burning, rapidly available, the fuel your body reaches for when demands are high or urgent. The second is fat, slow-burning, energy-dense, the fuel your body uses when it has sufficient time and sufficient oxygen to run the more complex extraction process. The critical word in that sentence is oxygen. Fat does not burn the way glucose burns. Glucose combustion is a relatively simple biochemical process, rapid, anaerobic in part, designed for speed. Fat combustion is a deeper, more demanding process. To convert stored triglycerides into usable energy, your cells require a sustained, abundant oxygen supply. They require time, and they require a specific enzymatic environment that only exists when your body is not under significant metabolic stress. Inside every muscle cell in your body are structures called mitochondria. If you remember one thing from school biology, it is probably that mitochondria are the powerhouse of the cell. But that description wildly undersells what they actually do. Mitochondria are sophisticated fat processing furnaces. They are the only location in your body where stored fat can be converted into usable energy. Everything else in the fat-burning pathway leads here. The process that happens inside your mitochondria when you burn fat is called beta oxidation. A fat molecule, a stored triglyceride, enters the mitochondrion and is broken down in a multi-step enzymatic process that requires continuous oxygen delivery. The output is ATP, your body's energy currency, produced slowly, steadily, and in an quantity per fat molecule compared to glucose. Here is the key. Beta oxidation runs optimally only when your muscles are receiving ample oxygen, only when your cardiovascular system is not being overwhelmed by the demand for rapid fuel delivery, only when your body is in a calm, sustained, aerobic state, not in a stressed, urgent, high-demand state. The moment exercise intensity rises above a specific threshold, your body's oxygen delivery system cannot keep up with the energy demand. Your cells need ATP faster than beta oxidation can produce it. So your body switches fuels. It shifts toward glucose, which burns faster, requires less oxygen per unit of ATP, and can be accessed almost immediately. This switch happens not because your body prefers glucose. It happens because glucose is the only fuel that can keep up with the speed requirement. Fat cannot be processed fast enough to meet high-intensity energy demands, so your body leaves it alone and reaches for sugar instead. And here is the consequence that most exercising people have never been told. When you walk at an intensity that keeps your heart rate above approximately 70% of your maximum, you have crossed the threshold where fat is being preferentially burned. Your body has switched fuels. The visceral fat you are trying to reduce is being left untouched while your body burns through your glucose reserves. When you walk at an intensity that keeps your heart rate between 40 and 65% of your maximum, a pace where you can speak in full sentences without breathlessness, you are in the zone where beta oxidation runs at full capacity, where your mitochondria have the oxygen supply and time they need to pull stored fat, break it down, and convert it to energy. This is not a theory. A study published in the Journal of Applied Physiology measured fat oxidation rates at different exercise intensities and found that subjects walking at low to moderate intensity burned up to 67% more fat per minute than those walking at brisk high-intensity pace. Not because they were working harder, because they were working at the pace their fat-burning machinery was designed for. How fast is that pace? It is slower than most people walk when they are trying to exercise. It is the pace where you feel like you are not working very hard. The pace that feels almost too easy. That feeling is the fat-burning machinery running optimally, not a sign that you need to push harder. Have you been walking faster than this because it felt more productive? Tell me in the comments. This is one of the most common mistakes in the entire world of exercise, and it is completely invisible unless someone explains the molecular mechanism. If this is already changing how you think about your walks, subscribe. Tap the like button. It helps more people find this information. Understanding the pace is only the first layer. The second layer is understanding why walking faster does not just reduce fat burning, it actively works against it. When you push your exercise intensity above the aerobic fat-burning threshold, your body reads the effort as stress. Not metaphorical stress, literal physiological stress registered by your adrenal glands as a threat requiring an emergency response. Your adrenal glands release cortisol. Cortisol is one of your body's most powerful survival hormones. In a genuine emergency, a physical threat, a sudden demand for explosive movement, cortisol is exactly what you need. It floods your bloodstream with glucose for instant energy. It mobilizes every fuel reserve your body has for immediate use. And it sends a specific signal to your fat cells. Lock down. Do not release. We may need these reserves. Your body cannot distinguish between the stress of being chased and the stress of a brisk 45-minute power walk. The cortisol response does not know the difference. What it knows is that the demand on your system is high and that stored energy might be needed later. So it signals your fat cells to hold rather than release. But here is the detail that makes this genuinely consequential for belly fat specifically. Cortisol does not just prevent fat release during exercise. It preferentially deposits fat in the visceral region, the deep abdominal fat surrounding your organs. The abdominal fat cells have a higher density of cortisol receptors than fat cells elsewhere in your body. When cortisol is chronically elevated, as it is in people who regularly push exercise intensity above the aerobic threshold without adequate recovery, those abdominal fat cells receive a continuous signal to store and grow. Research published in Psychoneuroendocrinology found that chronic moderate to high-intensity exercise without adequate recovery elevated cortisol levels by up to 48% above baseline in sedentary adults. These were people exercising regularly who were producing a hormonal environment that actively drove visceral fat accumulation through the exercise they were doing to reduce it. Slow walking, by contrast, keeps cortisol almost entirely flat. Your heart rate stays below the threshold that triggers the adrenal stress response. Your nervous system remains in parasympathetic dominance, the rest and repair mode where your body feels safe. Your fat cells are unrestricted, and the signals flowing through your biology support fat release rather than fat storage. This is the biological paradox that most fitness culture has never explained. Trying harder with walking does not produce more fat loss, it produces less. Because harder walking crosses the threshold into cortisol elevation, which closes the fat-burning door and opens the fat storage pathway simultaneously. The third layer is what happens to your fat-burning capacity over time, not just during a single walk, but across weeks and months of consistent slow walking. Your mitochondria are not fixed structures. They are dynamic. They multiply, they grow, they improve their efficiency in direct response to the metabolic demands you regularly place on them. And the specific demand that drives mitochondrial adaptation most powerfully is sustained, oxygen-rich, low to moderate intensity aerobic exercise, exactly the type produced by slow walking done consistently. 2022 paper published in Nature Metabolism found that consistent low-intensity exercise increased mitochondrial density in muscle cells by up to 40% over 8 weeks. More mitochondria means more fat-burning furnaces operating simultaneously in your muscle tissue. More furnaces means more fat oxidized not just during exercise but throughout every hour of your day, while you sit, while you work, while you sleep. Slow walking does not just burn fat during the walk. It physically rebuilds the cellular machinery that determines how much fat your body burns around the clock. The adaptation is permanent as long as the stimulus continues. Stop walking and it reverses over weeks. Walk consistently and it compounds indefinitely. Now let me give you the complete practical protocol, the specific pace, the optimal timing windows, and the habit structure that allows slow walking to produce the body composition results that most high-intensity approaches fail to deliver consistently. The pace you are looking for. A conversational walk. A pace at which you can speak in full sentences without pausing for breath. A pace that feels almost embarrassingly easy if you are used to exercising hard. This places your heart rate at approximately 40 to 65% of your maximum. The zone research identifies as peak fat oxidation. If you have a heart rate monitor, aim for 100 to 120 beats per minute depending on your age and fitness level. If you do not, use the talk test. Full sentences, no breathlessness, a slight warmth building through your body, but never the feeling of being genuinely pushed. This pace is not a compromise. It is not the beginner version waiting to be upgraded. It is the molecularly optimal intensity for beta oxidation. Slower than this, and the metabolic benefit is minimal. Faster than this, and you move out of fat oxidation into glucose burning and cortisol elevation. The three timing windows that amplify the result. The first window is the morning walk. 20 to 30 minutes of slow walking taken before breakfast, after the overnight fast has been running for 12 or more hours. Insulin is at its daily low. Liver glycogen is partially depleted. Your body is already shifted toward fat as a fuel source before you take the first step. The morning walk enters this hormonal environment and extends it, pulling from visceral fat stores in a state where the fat-burning signal is already active. Research in the Journal of Biological Rhythms found that morning walkers accumulated measurably less visceral fat over 12 weeks than evening-only exercisers with identical total step counts. Timing matters independently of quantity. The second window is the post-meal walk. 10 to 15 minutes of slow walking within 20 to 30 minutes of finishing any meal. When you eat, blood glucose rises, insulin responds. In a sedentary body, this post-meal insulin elevation actively suppresses fat oxidation for 2 to 3 hours. Your body is in storage mode, directing nutrients into cells and signaling fat tissue to hold rather than release. This post-meal suppression happens 3 or 4 times a day in most people's lives, meaning fat oxidation is blocked for the majority of waking hours. A slow post-meal walk intercepts this process at its source. Your leg muscles begin absorbing glucose directly from your bloodstream, without requiring insulin to mediate the process. The blood glucose curve flattens. The insulin spike is blunted. The fat-burning suppression window shrinks from hours to minutes. A study published in Diabetes Care found that a 15-minute slow walk within 30 minutes of eating reduced post-meal blood glucose spikes by 37% compared to remaining seated. 3 post-meal walks daily transforms your body's metabolic state for most of the day. The third window is the evening wind-down walk. 15 to 20 minutes of gentle, slow walking after dinner, in the hour before your sleep preparation begins. This walk does something neither of the other windows does. It activates your parasympathetic nervous system, the rest and recover mode, at the time of day when cortisol naturally needs to be falling to allow deep sleep to occur. Evening cortisol elevation is one of the most consistent predictors of disrupted deep sleep in modern adults. And disrupted deep sleep is one of the most powerful drivers of visceral fat accumulation. A study in Sleep Medicine Reviews identified poor sleep quality as one of the strongest independent predictors of visceral fat accumulation, stronger than diet quality, and stronger than exercise frequency. When sleep is shallow or disrupted, hunger hormones dysregulate, cortisol baselines rise, and fat storage is actively promoted regardless of what you eat or how much you move. Your evening walk is not just digestive support. It is an investment in the hormonal environment of your sleep, and therefore in the fat metabolism that runs through every night of consistent deep rest. The compound effect over time, a single slow walk produces a modest fat-burning response. 20 consistent slow walks produce measurably improved mitochondrial density. 90 consistent slow walks, 3 months of daily walking at the right pace, produce a body with fundamentally different cellular fat-burning capacity than it had at the start. The lipoprotein lipase enzyme, which pulls fat from your bloodstream and feeds it into muscle cells to be burned, is chronically upregulated by consistent low-intensity walking. More enzyme production means more fat pulled from circulation. More fat pulled from circulation means less available for storage. Less available for storage means existing visceral fat is drawn upon to meet energy needs. This is not a workout program. It is a metabolic remodeling process. It does not feel dramatic because it is not dramatic. It is quiet, biological, and cumulative, and it produces results that high-intensity approaches consistently fail to match over 6-month and 12-month timeframes in head-to-head research. A 2023 meta-analysis across more than 14,000 participants found that daily low to moderate intensity walkers lost significantly more visceral fat over 6 months than people performing high-intensity interval training 3 times per week. The mechanism was not mystery. Daily slow walking chronically upregulated fat oxidation pathways that 3 times weekly high-intensity exercise did not. Your visceral fat is not stubbornly resistant to change. It is responding precisely to the signals your body is receiving. Change the pace, change the timing, change the consistency. The biology follows. What surprised you most in this video? The cortisol mechanism, the pace finding, or the mitochondrial adaptation? Tell me in the comments. If you enjoy the quiet science happening inside your body, subscribe for more. New videos every week. In the next video, we explore something directly connected. What happens inside your fat cells during fasted morning walking, minute by minute, and why the combination of overnight fasting with slow morning movement produces cellular fat burning that neither habit produces alone. Your body is not failing you. It has been waiting for the right information. Now you have it.